Okay, dear students, missing you greatly, I must say. This is just not a lesson, it's just a short intro to what's coming up. I've decided, because students find connected particles difficult to do with the forces involved here, I've decided to break it down and look at every single case that you're going to come across at AS Maths. Okay, so this is when we join a couple of blocks together, and I'm going to go through actually 6 lessons with you. So connected particles, as you can see here, very clever of me. I did boxes and connected them with a little string or rod there. So in the first lesson, I'm going to look at just 2 blocks joined by a tight string and pulled along on the horizontal, and then what happens when we just turn it, so we lift it up and one's dangling beneath another one. So we're going to look at those 2 sort of situations. In the second lesson, what I'm going to do is I'm going to thread those over a pulley, and then we're going to release it from rest, and if one's heavier than the other, then it's going to fall and sort of go down. Okay. In the third lesson, I'm going to do pulleys again. I'm going to continue with pulleys, but I'm going to look at harder examples of them. When we get equations of motion involved. We're going to look at mild peril in that one. We're going to have what happens when the string snaps. Wow. Okay. And one hurtles, or they both hurtle towards the earth. Okay. So we're going to look at that. Then we're going to change our string. In the fourth lesson, we're going to change our string to a rod. Okay, so what happens when we change it to a rod? It's almost the same, but it allows us to look at a different situation, that not just when things are speeding up, but when things are slowing down. When these slow down, when this one slows down, this one, because it's only a string, it just bumps into the back of it. But here, that we've got a tension in this tow bar, but when this decelerates and slows down, it backs up and creates what we call a thrust. So it allows us to look at a different situation here. So we're going to look at cars and caravans, or cars and trailers. In the fifth lesson, my least favourite is this, what we call, you get questions in Edexcel called on a scale pan, of a block sat on another block in a pulley system, being lifted up. They call them scale pans. So just pulling up on this string, 2 strings down, and a platform, and lifting up a couple of blocks, and the forces involved there. So we're going to look at examples of that. Edexcel like this one. They also like putting people in lifts and lifting them up, and that lift accelerating up or accelerating down, up and down a mine shaft or a tall building. So we're going to look at those in lesson 5. And finally, we're going to finish with combining some of these. So a bit of horizontal travel and a pulley on the edge of a table, and something hanging over the edge that it starts to move, slides along the table as the other one drops to the floor. So we're going to look at combinations at the end, and that's our 6 lessons. So simple connected with a string over a pulley, 2 lessons on this, difficult pulley questions, caravans and cars, lifts if you like, going up and moving up and down, and combinations of those. This actually will set you up for next year. There's not much more to add to it next year. If you understand all of this, the only thing we have to do next year is look at these situations. You can see these are all horizontal or vertical. But what happens if this is on a slope? This block is on a slope, or this car is dragging a caravan or a trailer up a hill. So we're going to look at those next year. And we're going to look at friction in a little bit more depth. Now I'm going to try to avoid talking about friction at AS level, because it's almost not there. When I say almost not there, there is a little bit of friction that they add in, but they just add it as a simple force. So we're going to add friction, probably at this stage here. We'll say there's some friction between the block and the table, because in real life there would be. Okay, there'd be friction here. We were dragging that across, but we're not going to look at friction there. We're going to say it's so smooth there's no friction at all. Not really, but that's what we're going to do. So we're going to look at friction in more depth. There is more to it than just a simple force. There's a way of breaking down that force, but that only comes into A2. So this is our roadmap, if you like, and I've looked at every sort of case that I've ever seen over the last 25 years, and these 6 lessons that I'm going to do for you will cover all of those. And the way that I'm going to do those lessons as well is I'm going to give you a couple of examples, and then I'm going to give you a couple of questions, and then if you put the video on pause, okay, have a go at the questions, you'll be able to see those. It'll be 1 or 2 questions, that's all. So have a go from the lesson that you've just seen, from the short lesson that you've just seen on a particular case. Have a go, get an answer, press play, and watch me go through those questions to see whether you got it or not. Okay, so that's what we're going to do. And that's it. So there's my introduction. I don't normally read out subscribers' emails. I did get an email from Ollie over in Royston, and in his email he said, "Dear Mr. Mac, does Newton's second law, F equals ma, still apply in Royston?" So I looked up Royston on the map. It's in Cambridgeshire, and yes, Ollie, it does. F equals ma works, Newton's second law works across the whole universe, even in weird corners of the universe like Cambridgeshire, still works there. So yeah, so if you're doing your mechanics in Cambridgeshire, all of this will still work for you. Okay, hope you enjoy the first lesson. That's going to be part A. I've done a nice little sort of screen for you to, really gone to town on the setup and the presentation of these next 6 videos, which I think you will like. Okay, thank you.